All right, so now we're on the second video of this little series, and I'm going to actually work through these problems. So again, we have two knowns. I'm going to work a little fast because I'm on a time limit. And my second known and my unknown is moles of H2O. Okay, so my relationship 1 has to relate hydrogen, because that's my known 1, to my unknown. So it's going to be 2 moles of H2 to 2 mole of H2O. My second relationship will be from my second known, which is O2, to my unknown, which should be the same thing both times. 1 mole of O2 to 2 mole of H2O. Now to set this up, we solve one at a time. So I'm going to start with my first known, and I'm going to do 2.5 grams of H2. Just like before, nothing goes here. And if I have grams of H2 here, it needs to match diagonally so that it cancels out. Neither one of these relationships has it, so you have to actually come up with another one. And that relationship, if you look up here, we're starting in grams A. I need to get to moles A, so we're going to use the molar mass. Well, so, if you wanted to keep track of it, 1 mole of H2 is equal to the mass off the periodic table, which is 2.02 grams because there's 2 hydrogens. So grams needs to go on bottom. So I'm going to pull that grams part down with the 1 mole on top. Now I'm not to my unknown yet. My unknown was H2O. I'm not there yet. So I have to extend it another step. I just got to mole A by using the molar mass of A, which was that 2.02. Now I'm going to get to mole B using the mole ratios from the coefficients, which is going to be this relationship. But if H2 is on top, then I need mole of H2 on bottom, which means I need the flipped version of this. So it's going to be 2 mole of H2 to 2 mole of H2O. Okay, so if I solve this, you do 2.5 times 2 divided by 2.02 divided by 2. And you get 1.24 moles of H2O. It'd really be 1.2 if you use correct sig figs, but I'm kind of hurrying here. Okay, now we're going to do the same thing, but with our known 2. 21 grams of O2. Nothing goes here. I need to cancel grams, which means I need my molar mass. Oxygen weighs 16. There's 2 of them, so 32 grams and 1 mole of O2. This time my relationship has O2, which means I need this relationship and I need it flipped. So the 1 mole of O2 goes on bottom. The 2 moles of H2O go on top. 21 times 1 times 2 divided by 32 divided by 1 gives you 1.3 mole of H2O. Just like with every problem, you're going to solve it twice, but only one of these answers do I ever want to see boxed, which is going to be the smaller answer of the 2. That is your theoretical yield. Now that's all the problem pretty much asks, so that's your answer. But I'm going to extend it just a minute. And remember, whatever it is that makes your theoretical yield, that's your limiting reactant. And whatever it is that made the larger number, that is your excess reactant.